This video is about the scientific method, looking at why do we care? What's the point of it? What's the process? And we'll get a little bit into what hypothesis and theory are. So to start things off with the scientific method, it's been around for a long time. As in back in the early to mid 1500s is when we're looking at the scientific method. It was Sir Francis Bacon that first put this terminology, scientific method, and a process in place. Now, that doesn't mean that before him there wasn't inquiry and questions and the whole idea anyway, but he pretty much made it an official process. Now, the idea of the scientific method is to allow a scientific approach to answering a question that can then be repeated by other individuals. The main goal here is to make sure that whatever conclusion is drawn can be checked and rechecked and have the same conclusions come about from the same experimentation. It needs to be repeatable. So, why do we even care? Well, the scientific method allows us to create understanding from questions. It allows us to test things in a scientific nature to make sure that it's not just someone's thought or idea coming about, it's something that can be checked by other people, especially individuals that might have differing viewpoints. So, what do you care though about this? Why does anyone on a day-to-day basis care if they're not a scientist? Well, I'm willing to bet you probably use the scientific method without even knowing about it. Pick out your clothing. Well, sure, it might be based on fashion or styles or trends, but it still has to keep you warm enough or cool enough depending on the temperature. Middle of summer, probably wear something that's more summer-based. Shorts, t-shirts, something like that. But when we get into early fall, let's say September, October around here, well, you could have some warmer days. You could have some cooler days. So here's your question. You get up, what do you wear? Well, you're not going to do a lot of thinking about it. It's going to be, okay, this or that. Well, you pick something. All right, is it the right thing? I don't know. Let's test it out. We go outside. If it feels right, you're not too hot, not too cold, hey, all right, we're perfect. That's our conclusion. But you might say, I'm a little too warm or I'm a little too cool in this. Your hypothesis, what you thought the answer was, isn't correct. You gotta go back and reset. Change your clothing. Now, I'm sure you don't probably think of that in those terms as you're picking out your clothing, but there's many times throughout the day that you can make decisions based on things that you know, things you've researched before, and then you quickly test them to see if they're correct. Now, it'd be great if all scientific testing was that fast, but it's not. Sometimes these tests can go on for a very long time. So what is, though, the scientific method? Well, it really has 6 main steps. First step, question. You need to have a question about something. Now, hopefully, and it makes it easier if the question only has one variable. What I mean is, the questions only ask about one particular thing. Because if the question asks about 2 or 3 different things, now you have 2 or 3 variables, it's much harder to figure out which one is causing the impact when you're experimenting. You can do it, but it becomes more complex. So we have that question. What's the next step? Research. Next thing is to research your question. Find out as much information as you can about that question. Well, as you're researching, you're looking into things, eventually you'll form the third step, hypothesis. Now, the hypothesis is going to be an educated guess because you're still trying to answer the question. You haven't tested anything. You don't know what's going to happen, but from your research, you think you might know what's going to happen. Now, let's take a quick pause at that step. So we're on the step of hypothesis. The reason I'm pausing here is we just used inductive reasoning. Now, inductive reasoning is going to take all that research you did, or all those ideas, and combine them into one idea, the hypothesis. So inductive reasoning, you're taking all this in and creating one hypothesis, one idea, one thought. So inductive reasoning takes a lot and combines it into one thing. All right, back to hypothesis. Let's keep going. Once we have the hypothesis, we then need to experiment. The experiment is going to test your hypothesis to see if it's correct or incorrect. Now, again, a little sidebar here. Taking that one thought, the hypothesis, and then testing it, you're using deductive reasoning quite often. What deductive reasoning is you're going to take one idea and then you'll have several different points you can make from that one idea. So if you say this is your hypothesis, for example, you might say if the hypothesis is correct, then A will occur. If the hypothesis is also correct, B will occur. If the hypothesis is correct, C will occur, and so forth. So you're taking one idea, one thought, one hypothesis, and then you're bringing all these points off of that one idea, that one hypothesis. In the case of experimentation, the experiments are the deductive reasoning from your hypothesis. All right, back to the whole process. So we have the question, we then have the research, we then have the hypothesis, we then have the experiment, then we move into analyze. In the case of analyzing the data, you're going to take all that experimental data and then you're going to analyze it to try to figure out what does it mean. So once you're analyzing, your last step, conclusion. Conclusion is what you'll draw from all the analysis. Basically, you're trying to figure out your conclusion. Was the hypothesis correct or was it incorrect? And now at any point through the process here, you might need to restart because maybe your experiment didn't work. You have to then start a new experiment. Maybe in the analysis phase, you realize that there was an extra variable in there you're trying to figure out. You got to restructure. Or maybe you made it all the way to the conclusion and then you realize, you know what? Sure, we made the hypothesis and we affirmed it. It's correct. But we now have these 1, 2, 3, 4 other questions we have. So you keep starting the process over to make it go again. The scientific method is a never-ending cycle. It's a constant process where you have questions upon questions that you're always trying to answer. But one of the biggest things is once you've completed the process and reached conclusion, somebody else should be able to look at that question, follow your experimentation, and then see the same conclusions. So an experiment through the scientific method should be repeatable, should be able to be used over and over again. And that's how a lot of times peer-reviewed journals work. Someone submits a paper on their work, their experiments. Other scientists will look and see, does this make sense? Did it follow process? And go from there. So the idea here is, though, those were hypotheses you are testing to see what's going on. We have to look at hypothesis versus theory. And we'll take theory in the scientific way. A hypothesis, educated guess. A theory is once the hypothesis has been tested over and over and over, sometimes hundreds of times, where everyone agrees then that tested that, hey, this is correct. This is what happens. Now, in the case of a theory, usually most people accept theories as a truth. the theory of gravity. I'm pretty sure all of us have our feet planted on the ground. That works. So when you start looking at the different theories of science, they've been proven time and time again as you go through research. But with every theory, there's always a chance of new information. Take the theory of gravity. Go back 1,000 years. They didn't have it. They didn't have this theory of gravity. They didn't have the theory of gravity until someone started testing over and over all these objects falling from the sky. If you take something, you drop it, it falls. Gravity. But you had to look at how the objects fell and explain, well, why do objects fall at different rates, at different speeds? Well, it takes into account velocity, it takes into account air resistance, it takes a lot of things into account why a feather falls slower than a bowling ball. They both fall at the same speed from gravity, but the feather has more air resistance. Put in a vacuum, they drop the same way. So the idea of theory, been proven over and over, versus hypothesis. It's an educated guess what they think will happen. Now, one note, the term theory. There's a scientific term we just talked about. It's been proven over and over. And there's more of the everyday term theory. You might be talking with somebody and say, I have a theory about that. It kind of means you have a thought or idea about it. So we're looking at theory as the scientific term, the theory of gravity. It's been proven over and over. So that's the scientific method, theory versus hypothesis. Until the next video.